Hello students, I welcome you all to my YouTube channel Ritika Chemistry Classes. I request you all to subscribe my channel so that you stay updated about my upcoming videos. Thank you. So now let's begin. In the previous lecture, we studied about black body radiation and photoelectric effect. In both of these phenomena, we found that the electromagnetic wave theory, which considers the wave nature of light or radiation, failed to explain these phenomena, while the Planck's quantum theory, which considers the particle nature of radiation, was successful in explaining both of these phenomena. Also, there are certain other phenomena like interference, diffraction, etc., which can be explained only considering the wave nature of light. So, there are phenomena which can be explained considering the particle nature of light, and there are certain other phenomena which can be explained only considering the wave nature of light. So, it was said that light possesses dual nature, that is, it behaves both as particle as well as wave. So we were also discussing about models of the atom. In the Rutherford's model of atom, we saw that its model failed to explain the stability of atom as well as the line spectra of various elements. So in order to overcome the drawbacks of Rutherford's model of atom, Niels Bohr proposed his own model known as Bohr's model of atom in 1913, which was based on Planck's quantum theory. So today's topic is Bohr's model of atom. So this model of atom was given by Niels Bohr in 1913, and this model was based on Planck's quantum theory. So what were the postulates of this model of atom? Write down. First postulate is, according to this model, an atom consists of small, heavy, positively charged body at the center known as nucleus. Okay, so according to this model, an atom consists of a small, heavy, positively charged body at the center of the atom known as nucleus, and the electrons revolve around this nucleus. Second, the electrons revolve around the nucleus in only selected circular orbits having fixed energy. That is, the electrons revolve around the nucleus in only certain selected orbits which having fixed energy. And these orbits are known as energy shells. These orbits are known as energy shells or energy levels or stationary states And these energy levels are numbered as 1, 2, 3, 4 and so on, or they are designated as K, L, M, N and so on, starting from the nucleus, starting from the energy level that is closest to the nucleus. If this is our nucleus and this is our first energy level, then we have second, then we have third energy level. So the first energy level is numbered as 1 and is designated as K shell, second as number 2 and as L shell, and third is as n equals to 3 and designated as M shell, and so on. Also, as long as the electron remains in a particular orbit, it neither lose energy nor gain energy. That means the energy of the electron in a particular orbit remains constant. Next. So we saw that the energy of the electron in particular orbit remains constant. So what is the value of this energy? Write down. 4 hydrogen-like atoms like helium positive, lithium 2 positive, etc. So what are hydrogen-like atoms? Hydrogen-like atoms are atoms having only one electron. These are the species which are having only one electron. As we know, helium having atomic number 2 has 2 electrons, but it is helium positive. That means it has lost 1 electron. So helium positive has only 1 electron in its atom. So for the hydrogen-like atom, the energy of electron in nth energy level is given by En, where En denotes the energy of electron in nth energy level. It is equals to minus 2 pi square m v square e to the power 4 upon n square h square, where m is the mass of electron, v is your atomic number, e is the charge on electron, n is the number of shell, and h is the Planck's constant. So as you know that this m, e and h, all these are constant. So substituting the values of also 2 pi square. So substituting the values of all these constants, we get the value of energy as En is equals to minus 13.6 v square upon n square electron volt per atom. If we want to calculate this energy in terms of joule, we know 1 electron volt is equals to 1.6 into 10 raised to power minus 19 joule. This is the relation between electron volt and joule. So the energy of electron in nth orbit, it becomes equal to minus 21.8 into 10 to the power minus 19 v square upon n square joule per atom. This is the value of energy in terms of joule. If we want to find out the radius of orbit, so write down for hydrogen-like atom, radius of nth energy level is given by energy level, or you can say orbit, is Rn. It is denoted by Rn. Rn is equals to A naught n square upon Z, where A naught is a constant. Write down, where A naught is a constant whose value is equals to 52.9 picometer. Whose value is equals to 52.9 picometer. So what is this A naught? Write down A naught. If in the Rn you substitute the value of n and z as 1, if n is equals to 1, that means first orbit, and z equals to 1 means hydrogen atom. So for that Rn will become equals to A naught. So A naught is the radius of first orbit in case of hydrogen atom, and this A naught is also known as Bohr's radius. This A naught is also known as Bohr's radius. Write down. If you want to find out the velocity of electron, write down the velocity of electron in nth orbit, which is denoted by Vn. It is equals to V naught into Z upon n. Vn is equals to V naught into Z upon n, where V naught is a constant whose value is equals to 2.188 into 10 to the power 8 centimeter per second. Centimeter per second. Write down third postulate. Third postulate of Bohr's model of atom. So, as the electrons revolve only in those orbits which have fixed value of energy, so the electron in an atom can have only certain definite value of energy and not any value of its own. So it is said that energy of electron in an atom is quantized. As you already know, quantized means having certain definite value. Write down fourth point. Like energy, angular momentum of the electron, like energy, angular momentum of the electron in an atom. Angular momentum in an atom can also have only certain definite value. It cannot have any value of its own. So angular momentum is also quantized. So the angular momentum of an electron is also quantized. And mathematically it is represented by mvr is equals to nh upon 2 pi, where you know that mvr is your angular momentum, where m is the mass of electron, v is the linear velocity, r is the radius of orbit, and n is the energy level, and h upon 2 pi you all know is a constant. So angular momentum is a multiple of h, integral multiple of h upon 2 pi. Write down last postulate, which is postulate number 5. Energy is emitted or absorbed only when an electron jumps from one orbit to other. So according to this postulate, the energy of electron in any particular will be constant. But energy is emitted or absorbed only when an electron makes a jump from one energy level to other energy level. Let us explain this postulate. So if this is this is the nucleus and these are the orbits in which electron revolve around the nucleus. So let's suppose when an energy is supplied to an atom, so the electron in an atom will absorb those energy. Let's suppose we are giving energy to this electron. So this electron will absorb this energy and it will jump to higher energy level. This is energy level 1, energy level 2, energy level 3. So the electron will jump from, let's suppose n equals to 1 to say n equals to 3. And this state of electron is known as excited state. And as you know, the lifetime of an electron in an excited state is very short. So the electron in this excited state will come back to the ground state by emitting energy in the form of radiation. Let us see. If this is the again nucleus and these are the orbits in which our electrons revolve. So after gaining this energy, the electron is now here in energy level 3. So this state is the excited state and will unstable. So electron will come back to its ground state by emitting energy in the form of radiation of suitable frequency or wavelength. The amount of energy emitted or absorbed is represented by delta E, which will be equals to E2 minus E1, where delta E is the amount of energy emitted or absorbed and E2 minus E1 is the difference in energies of two energy levels concerned. Okay, that means that energy levels between which the transition is occurring. So these are the postulates of Bohr's model of atom. Now let us see what are the advantages of this model of atom, or how this model of atom explains the stability of atom or line spectra of atom. Write down advantages. So first advantage of Bohr model of atom is it is helpful in explaining the stability of atom. As we saw from the postulates of Bohr's model of atom, that as long as the electron remains in a particular orbit, it neither gain nor lose energy. So the electron will keep on revolving in those orbit, in that particular orbit. So the question of losing energy continuously and then eventually fall into the nucleus is not valid here. Second, line spectra of hydrogen atom. So this model of atom was also helpful in explaining the line spectra of hydrogen atom. Although an atom of hydrogen contains only one electron, Yet the spectrum of hydrogen atom consists of a large number of lines. So we will explain how this large number of lines exist in the line spectrum of hydrogen. So any sample of hydrogen consists of a large number of molecules. So when energy is applied to any such sample, the hydrogen molecules are dissociated to hydrogen atoms. So hydrogen molecules will be dissociated into hydrogen atom. So on giving energy to such a sample, different hydrogen atoms will absorb different amount of energy and they will get promoted to different higher energy levels. Let's suppose some electrons in the atom are excited to second energy level, while some are excited to third energy levels, while the electrons in some atom are excited to fourth energy level, and so on. And as you know that the lifetime of electrons in the excited state is very short, so they will come back to their ground state or lower energy levels by emitting energy in the form of radiation. So the electrons in different atoms will follow different path to come back to their lower energy levels. So different electronic transitions will give rise to different lines in the spectrum. Let us see. You know that energy of electron is given by minus 13.6 z square upon n square electron volt in terms of electron volt. For hydrogen atom, the value of Z is 1. So En will become equals to minus 13.6 upon n square electron volt. So for n equals to 1, we get the energy equals to minus 13.6 electron volt. For n equals to 2, it will become minus 13.6 divided by 2 square, which is equals to minus 3.4 electron volt. For n equals to 3, it will be minus 3.6 upon 3 square, which is equals to minus 1.51 electron volt. Similarly, for n equals to 4, we get E4 equals to minus 13.6 divided by 4 square, which is equals to minus 0.85 electron volt. So from these values of energies, you can see that the gap between these two energy levels is very large, and the energy gap between these two energy levels is smaller than this gap, and the gap between these two energy levels is again smaller than both of these energy gap. So as we move towards higher energy level, we saw that the energy gap between successive energy level goes on decreasing. So if we plot energy levels, if we want to see the spectrum of hydrogen, let's suppose this is n equals to 1, this is n equals to 2, n equals to 3, 4, 5, 6, 7, 8, and so. So we saw that the energy gap between first and second energy level is the highest, and the gap between successive energy level, it goes on decreasing. So if we talk about the line spectrum of hydrogen atom, so we saw that when the energy is supplied to different hydrogen atoms, the electrons are excited to different energy levels. So from n equals to 1, they will be excited to n equals to 2 or 3, 4, 5 or so on, any energy level. And then they will return, come back to lower energy levels by emitting energy of certain wavelength, or we can say frequency. So let's suppose the electron gets excited to n equals to 8 and it comes back to n equals to 1. Or the electron in n equals to 7 comes back to n equals to 1. Or electron in n equals to 6 comes back to n equal to 1, or like this. So in all this transition, what is happening? The electrons from higher energy levels are coming back to the energy level n equals to 1. So the lines corresponding to this series is known as line 1 series. This set of lines obtained are known as line 1 series. It is also possible that electrons from higher energy levels, after transition, they come back to energy level n equals to 2. So the various possible transitions are like this. So these set of lines, which are the transition of electrons from higher energy levels to energy level n equals to 2, are known as Balmer series. So it is also possible that electrons from higher energy levels come back to the lower energy level having n equals to 3. So this set of lines is known as Paschen series. It is also possible that electrons in higher energy levels, after transition, they come to energy level n equals to 4. This set of lines is known as bracket series. Similarly, moving further, we get Fund series. So due to this reason, we get a lot of lines in the hydrogen spectrum. So if we talk about the amount of energy emitted, write down what will be the amount of energy emitted. The amount of energy emitted will be denoted by delta E, which will be equals to E2 minus E1, where E2 is the energy of the electron in energy level N2, which is higher energy level, and after the transition it comes back to lower energy level N1 having energy E1. And as we have studied that the energy of electron in nth orbit is given by minus 2 pi square m e raised to power 4 z square upon n square h square. In case of hydrogen atom, the value of z will be equals to 1. If we want to write this energy in terms of SI units, in SI units, En will be equals to minus 2 pi square m e to the power 4 z square upon 4 pi epsilon naught square n square into h square. For hydrogen atom, the value of z will be 1. So I am substituting the value of v equals to 1. So this is the energy of electron in case of hydrogen atom in nth orbit. Substituting this value in this equation number 1, we get delta E equals to minus 2 pi square m e to the power 4 upon 4 pi epsilon naught square n 2 square h square, where E2 is the, we know, energy of electron in n2 orbit, minus of minus 2 pi square, this minus is this, and the value of E1 will also starts with the negative, so this negative is because of energy. So minus 2 pi square m e to the power 4 upon 4 pi epsilon naught square n1 square upon h square. Delta E is equals to h nu, so we have written delta E equals to h nu, and this minus minus will become plus. So write down upon 4 pi epsilon naught square and 2 square upon h square, minus minus plus 2 pi square m e to the power 4 upon 4 pi epsilon naught square and 1 square h square. So from both these equations we can take 2 pi square m e to the power 4 upon 4 pi epsilon naught whole square upon h square as common. So this is positive term. From this we will get only 1 upon n1 square. This negative. From this term we will get 1 upon n2 square. This, as we know, C is equals to nu into lambda. So nu will be equals to C upon lambda. This lambda will goes on left hand side, so it will become C upon lambda. So substitute the value of this nu in this equation. We will get hc upon lambda is equals to 2 pi square m e to the power 4 divided by 4 pi epsilon naught whole square h square 1 upon n1 square minus 1 upon n2 square. Okay. So now divide whole equation by hc. Divide whole equation by hc. If we will divide left hand side by hc, then numerator and denominator it will get cancelled out, and we will get only 1 by lambda. And 1 by lambda is represented by nu bar, which is known as wave number. And this is equals to, now we will also have to divide right hand side by hc. So we will get 2 pi square m e to the power 4 divided by 4 pi epsilon naught whole square. Here it is h square, so it will become h cube into c, into 1 upon n1 square minus 1 upon n2 square. So nu bar is equals to, you know, m is mass of electron, which is constant, E is charge on electron, which is also a constant value, 4 pi epsilon naught is also a constant value, and h and c, you also know that these all are a constant value. So this whole term is a constant, is some constant, and this constant is represented by RH, known as Rydberg's constant. There RH is Rydberg's constant. And its value is 1.09 into 10 to the power 7 per meter. So if we want to see the units, this is Rydberg's constant RH. So in the right hand side it is n1 square minus n2 square. You know n1 square represents the orbit which has no dimension. So this is dimensionless. This is Rydberg's constant whose units we want to find out. And in left hand side we have wave number, which is 1 upon lambda. and you know the units of wavelength is of distance, either meter or centimeter. So 1 by lambda will become 1 by meter or 1 by centimeter. So that's why the units of Rydberg's constant is per meter. Thank you.